Hello, I'm going to demonstrate how you can optimize feed rates and spindle speeds automatically from your own Mastercam seat using SenseNC Finesse, the Productive Machines plugin for Mastercam. A seamless integration makes this process as straightforward as possible. At Productive Machines, we're combining physics models of the cutting process and machine dynamics alongside the CAM package in a CAM meets physics approach. This means that customers have experienced a 20% reduction in cycle times, a 10% reduction in wear and tear, and a 40% smoother surface finish. As you've seen from the video, it's quite straightforward to get started, and we're now selecting the operations we'd like to optimize. Before going on to tell the system about our tooling properties. We use a tooling database, which means that once a tool has been configured within your organization, there's no need to do it again, and you can simply import from the existing database. Here we can see the tool we're after, so we'll make the selection, and then we'll save the tool. If you had multiple tools, then you would move on to select the next tool in the list, confirming its properties until you've completed all the tools. Finally, we just need to select a material and then request the optimization. This extracts the toolpath and the in-process workpiece information about the stock and sends that off for optimization. This is a while-you-wait service, so you can close Mastercam down, go submit another optimization, or do something else with your laptop. The system will email when your job is complete. I'll now show you how to import the result from a previous submission. So here at the top, we can see the one we've just done, but we'll select one that we prepared earlier. And here you can see the two operations we requested. And then we need to select the productivity level. This controls the optimizers. A higher setting would set a higher feed rate or spindle speed according to the type of operation that you've asked for an optimization. With that selected, we import the toolpaths. And we can see these will get updated automatically in the background of Mastercam and can then be ran through your standard post-processing workflow before being moved onto the machine. Okay, and that's an import complete. You saw on there that we have a download report service, and this tells you about the optimized toolpath in terms of the cycle time reductions, chatter avoidance, and a description of the forces and stability behavior of the tool along that toolpath. Here we can see a summary of a typical report, and you can see here that a productivity saving cycle time reduction of 24% was obtained, alongside completely eliminating chatter on this toolpath. I'll quickly scroll through the reports. You can see the type of data we give you, from the optimized and original feeds and speeds, through chip thicknesses, finally onto the force loadings on the tool, and then we get to a stability map. This describes the chatter behavior along that toolpath. And you can use this to problem solve troublesome toolpaths or just understand the optimizations that we've provided. So along the x-axis, you're looking at the distance traveled along the toolpath, whilst the y plots the maximum spindle speed of the machine you requested an optimization for. The color map here describes the severity of chatter, with the white regions meaning there's no chatter, and then the colored regions showing progressively worse chatter as it goes from blue to red. In the case of this toolpath, you can see that there are clear channels along the path where a single spindle speed will give you a completely chatter-free optimization. And this is what our software works to find. A higher productivity slider setting is more likely to select a higher spindle speed, but our software is designed to always stabilize the cut before attempting to increase feed rates. Thank you for listening to this demo, and we hope to hear from you soon.